the part that we have done is this part in this given point. So meaning that we are going now to in this particular video, we're going to have a discussion on how to perform question to do with binomial expansion. And we're going to look at this question whereby you are supposed to find the coefficient of x squared in the expression of 2x minus 5 root 4 minus x. How are you supposed to do this particular question? This is a question that you'll be able to be tested when you are doing P3 papers. So basically this video is going to enable you know exactly what are the steps that you are expected to follow in order to work out such kind of questions. And if you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload further tutorials, you'll be notified. Let's dive in so that we can be able to see what are the steps required in order for you to do this particular question. Let's begin by writing the question the way it is. We are told that we're supposed to find the coefficient, and whatever that we are finding the coefficient is actually given by 2x minus 5 Now, in order to work out this, the first thing that we're going to do first, we need to know what is the expansion of root 4 minus x. How can we be able to expand? So that's what we're going to do first. We need to expand this part. Once we have expanded the root of 4 minus x, then we're going to multiply it with 2x minus 5. So first we need to say root 4 minus x can be written as, we can be able to write this as 4 minus x raised to power a half, right? So which means that but for us to be able to use binomial theorem, we need the first term here to be actually 1. Yeah, so which means that we can be able to write this as further. I'll factor 4 out, so I'll say I'll factor 4 raised to a half out. I remain with 1 minus x raised to x over 4 then raised to a half. So when you are factoring this number that is inside out, you also take its power out, which will mean that this can be written as, this is the same as, we can say because 4 raised to a half is actually 2, the square root of 4, right? That is 2. So which means this is going to be given as 2 into bracket 1 minus x over 4 raised to 1 over 2. Now this is the part that actually we have at this given point that we are going to really try to expand. This part that we have here is the one that now we are going to expand using binomial theorem, right? So we can now conclude that this part of our equation is going to be given us, okay, we need to now say we can expand. This is the part that needs our expansion. This one here is the one that needs our expansion. Then we can now say our equation that we were having can be written as 2 into bracket 2x minus 5 then into bracket 1 minus 4 over 1 minus x over 4 raised to power 1 over 2. Okay, so we are going to ideally be working on this expansion now. What can this be expanded to? We are going to start by first looking at how does binomial expansion occur. So we are going to say, if you are having, according to binomial theorem, if you're having 1 plus x raised to power n, where n is a rational number, then we're going to say the expansion becomes, for instance, now we have 1 plus x raised to power n. This expansion becomes 1, right? We shall start by 1 plus xn, right? Then the next term will be nx. The next term will be plus n into n minus 1, right, over n factorial over 2 factorial, then x raised to power 2, right? Then the next term here will be n into n minus 1. Again, because we have done n minus 1, we are going to say now n minus 2 over 3 factorial x raised to power 3. And now the sequence continues like that. That is now according to binomial theorem. But now in our case here, then once we have the third term here, we shall say plus, the terms continues like that. So the next thing that we are going to do now is to simplify this expression that we have here. And we're going to say this is going to simplify to 1 plus, what is our n? Our n is a half times x. So this is going to be, because our x is negative 4, x over 4, because this value of x in our expansion here is negative x over 4, we're going to say this n times this, or x times n, we're going to get minus x over 8 at that point. But this one now, we're going to say this is going to be plus n. Our n is 1 over 2 into bracket 1 over 2 minus 1 over 2 factorial. 2 factorial is like 2 times 1. Then our x squared, our x is this, so we're going to say this is going to be minus x over 4 squared, and then the terms of the expansion continue like that. Because we are finding the coefficient, of x squared in this case, we are going to stop at that particular point, and then this is going to finally becomes 1 minus x over 8. Finally, this becomes 1 minus, go back to the original expansion, because we know that this part here can be represented by expansion. So we can say now this is going to be 2. Okay, our expansion was 2x minus 5. 2x minus 5. Let me just write it a little bit lower. This is 2x minus 5 square root of 4 minus x. This can be written as, we can be able to write this as 2x, 2 into 2x minus 5, and then 1 minus x over 4 raised to power a half. So already we have, Now, because we know that this expansion here represents this part, we can now say this is going to be equal to 2 into 2x minus 5. But instead of writing this, we are going to write this part, which is actually 1 minus x over 8, then minus 1 x squared over 128, and the expansion continues like that. So once we have this, I'll try to reduce this upper part that we have here a little bit, so that we can say this is going to be 4x minus 10 into 1 minus x over 8 minus x squared over 128, then plus dot, like that. So we're going to see which part will we multiply in order to get to a coefficient of x squared. So I can see here comfortably that if I multiply 10 and this, I can be able to get a coefficient of x squared. So that is going to give us terms, can say terms that gives x squared. Those are the terms that we are trying to look for, terms that will give us x squared. So if we multiply this, we are going to get here, this is negative and this is negative, so we're going to get 10x squared over 128. The next term that can give us a coefficient of x squared is actually 4x and x over 8, and this is going to give us negative 4x over 8, which is going to translate to a half. So which means that if we are looking at that, we are going to have what? So the next thing, we are going to factor x squared out so that we can be able to know what is the value of this. This is going to be 10 over 128 minus 4 over 8, and then we have x squared out. So if we work out this, we are going to get our answer being equivalent to negative 27 over 64 x squared. But in this question, we were told to x squared. The coefficient of x squared is actually this part that we have here. So coefficient, therefore coefficient of x squared in the expansion is negative 27 over 64 as our final is negative 27 over 64. So that is basically what you are supposed to get in this particular question. The next question that will be asked in this kind of question is to state the set of values for x for which this expansion is valid. The set of values for x for which this expansion is valid. So in that you expanded using the binomial formula. So once you identify this, you go and pick the value that you have there, and the value that we are going to pick is this value here, and this is going to be where this expansion is valid at where we have x over 4 negative modulus, or should be less than 1. So you're just picking this term, but remember, when we are talking of a modulus, it means we are going to take positive values only. So this is going to be x over 4 less than 1, which implies that this can be written as we can factor the 4 out, 1 over 4 out, and then we end up having 1 over 4 modulus of x. Because this 4 is a constant, then we are going to say is 1. Then you multiply by 4 both sides, because this is